All right, guys, so this is to review some right triangle trig that we learned in geometry. Now, if you recall, hopefully you do, we want to remember SOHCAHTOA. Okay, and remember the SO stands for the sine of some angle is going to equal the opposite over the hypotenuse. And then the cosine of some angle is going to equal the adjacent side over the hypotenuse. And last but not least, I have room, so I'm going to come down here. The tangent of some angle is equal to the opposite side over adjacent side. And if you know that, the rest is fairly simple. All right, so if we look at example 1, here we're trying to solve for theta, which is an angle measure. Okay, so this is our reference angle. So I want to label each of the three sides H, O, and A. So my hypotenuse is always opposite of the 90-degree angle. So this is my hypotenuse. My opposite is always opposite of the reference angle. So this is my opposite. The one that's left is my adjacent. Okay, so now I want to see, well, what two sides do I know? Well, I know the adjacent and I know the hypotenuse. Okay, so now that I know the adjacent and hypotenuse, I want to go up here and say, okay, well, where is adjacent and hypotenuse put together? And you'll see it is right here in cosine. Okay, so I can say that the cosine of some angle is equal to A and H, so adjacent over hypotenuse. Okay, well, cosine of theta, I know my adjacent and hypotenuse. My adjacent is 12, my hypotenuse is 13. Okay. But when I'm looking for an angle, okay, remember we have to use the inverse, that cosine to the -1 thing. So I can say cosine inverse, and when I do the inverse, I flip these two. Okay, cosine inverse of 12 over 13 is equal to theta. Now, before you put this into your calculator, make sure your mode is in degrees and not radians. Okay, so if it is cosine of 12 over 13, if it is, you should get that theta is about 22.6 degrees. Okay, if you got something different when you put this in, chances are you're in radian mode, so you need to change that to degree mode. Please ask if you need help. All right, so I want you to pause this video and I want you to try to do example 2 on your own and see what you get. All right, so this time my theta is over here, so this will be my reference angle. So opposite of 90 is always my hypotenuse. Opposite of my reference angle is my opposite. The one left over is my adjacent. Okay, here I have my adjacent and my opposite. Okay, so if you look at SOHCAHTOA, which should be written at the top of your page, you're going to ask yourself, well, where is the? It's right here at the last part of SOHCAHTOA in the TOA. Okay, so we know that the tangent of theta is going to equal the opposite side over the adjacent side. Okay, so I can say tangent of theta equals, well, opposite is 4, adjacent is 13, and then once again, I'm looking for an angle measure, so I'm going to use inverse, and when I use inverse, these two things flop places. So 413 equals theta. When I put that into my calculator, I get that theta is roughly 17.1 degrees. All right, let's look at number 3. Here I'm looking for a side length. Okay, I can't use Pythagorean theorem because I don't know this side, but I do know we have a right angle, an angle measure, and one of the sides. So I know my angle B, so I'm going to let this be my reference angle. Okay, so same as I did before when I was looking for an angle, I label each of the sides. So this is my opposite side, this is my hypotenuse, and this is my adjacent. Okay, now I'm looking for my hypotenuse, and I have my opposite. So I want to know, where do I see H and O or O and H together? Okay, well, SOHCAHTOA Here's O and H together right here in sine. So what I know is that sine of some angle is going to equal my opposite side over my hypotenuse. Okay, well, sine of my some angle, I know the angle measure, it's 57. So sine of 57 degrees equals, well, my opposite side is 10.8 over my hypotenuse is x. Okay, now remember, guys, this is just a numeric value, and our calculator knows that numeric value. Okay, so I want to try to get x by itself. I'm going to leave it as sine is 57 now, so let's multiply both sides by x. Those go away, so I have x times sine of 57 degrees equals 10.8. Okay, now to get x by itself, divide by sine of 57. Divide by sine of 57. Those go away, so I'm left with x equals 10.8 over sine 57 degrees. So if I put that into my calculator, I get x is roughly 12.9-ish. Okay. And that's going to be my answer. All right, I want you to try example 4 on your own, and then we'll go over it. If you get stuck, look at example 3. It's very similar. All right, so hopefully you worked through this on your own, but this here's our reference angle because we know this is 60. Okay, so if I label each of the sides, this is my opposite side. Opposite of the 90 is my hypotenuse. The one left over is adjacent. Okay, well, I want to know my adjacent and I know my hypotenuse. So I'm looking for, where do I see A and H or H and A together? Okay, well, if I look at SOHCAHTOA, I have the cup heart that has A and H side by side. Okay, so I'm going to use cosine. So cosine of theta is the adjacent side over my hypotenuse. Okay, so cosine of, well, my angle measure is 60 degrees, equals my adjacent, I don't know, it's x, over my hypotenuse is 11. Okay, once again, I want x by itself. So to do that, I want to first get rid of the fraction. So multiply by 11, those go away. So I have 11 times cosine of 60 equals x. Get x is 5.5 on the dot. That is my final answer.